The test or the quiz is going to be about uh, more of the definite integrals, more like those ones, but it'll be good practice for us to just practice doing the antiderivatives first. So at this time, whatever we get done is what I want you to turn in. So let's take a look at problem number 1. The general antiderivative, we're going to use capital F when they use the lowercase f and they haven't put the little derivative mark on there. To do the antiderivative, remember the power goes up by 1 and we divide by the new power. So this is going to be 12x cubed divided by 3 plus 6x squared divided by 2 minus 5x plus c. Okay. For number 3, let's assume there was a number, I don't know, put a 5 there, who cares? Okay, it got chopped off a little bit. Number 3, the antiderivative is going to be 6x to the 10 divided by 10 minus 4x to the 8 divided by 8 plus 3x cubed divided by 3 plus 5x plus c. So those should be, I think, pretty straightforward when it comes to doing that. But let's take a look at number 5 and, some of these ones that require a rewrite. So let's start with 5. First thing I would suggest doing is make that 6x to the negative 5. When you add 1 to a negative 5, it becomes a negative 4. So it's going to be 6x to the negative 4 divided by negative 4 plus c. Okay. Now, please, when you're taking the quiz, reduce. Well, you aren't going to have to really. You can reduce ahead of time before you stick in the bounds. It's probably a good idea. Okay. Number 7, do a rewrite. Make that x to the 1/2 plus x to the negative 1/2 before you do your antiderivative. Okay. So when you do the antiderivative of 1/2, when you add that 1, you get 3/2. And just stick the reciprocal, because you're dividing by 3/2, just multiply by 2/3 instead. That's the easiest way to handle fractions. So here we would get x to the 1/2. When you multiply here by that reciprocal, you get 2. And then don't forget your plus c. Now, because the quiz, it has boundaries, there's none that require a plus c because it won't matter when you're doing the integral itself. Let's take a look at 11. You have to do a rewrite. That's 3x to the negative 2 minus 5x to the negative 4. So that's what you want to use before you do the rewrite. When you do the antiderivative. So if you add 1 to negative 2, it goes up to negative 1, and we have to divide by negative 1. Now you can put it over negative 1 or just put a negative 1 in front. I don't care. Okay. And then here, that's negative 5x to the negative 3 divided by negative 3. Just make that sign a plus when you're doing that, and then plus c. So any rewrite that we had done in the past, you're going to have to do a rewrite before you actually integrate. Or take the antiderivative, however you want to think about it. 13, remember to go backwards from a cosine. It originated as a sine, so it doesn't change its sign. But when you go backwards for a sine, you do have to change the sign, because cosine originally, when you take its derivative, has a negative. So this is going to be positive for cosine of t plus c. Now, do you see how 17 has different notation there? So if that's the derivative, one step backwards is the original. So, that would be x to the 5th divided by 5 minus 2x to the 3rd divided by 3 plus x squared divided by 2 minus x plus c. Now, I only want to do one like 25. Yeah, it's not on the I did not put one like this on the quiz, but I just want to remind you because it will be on the chapter test when that occurs. So let's take a look at 25 for a moment. The first thing we know is that f of x would be 4x squared divided by 2 plus 3x plus c. Now, the reason that they gave you this information right here is because if we stick in 0, we should get -9. So that will mean that your C is -9, okay? So if we stick in 0, we get -9, so C must be -9. So the actual final answer for this is 2x squared plus 3x minus 9. Okay, so now, if we could, let's do 43 because that's a neat one. So they've given us the acceleration. Again, I didn't put one of these on the quiz. It's just practice and integration. But anyway, I do want to do 43. So if you go backwards one step from the acceleration, that is your velocity. So that's going to be t cubed over 3 minus t squared over 2. And we would have to have that initial velocity sitting here. We don't have that information. So that's your plus c in this particular case. And that v sub 0 just means that is the initial velocity, the starting velocity, the velocity at 0. Okay. Now, if we go backwards to our position function, we're going to do it again. So this time it's going to be t to the 4th divided by 4. So just multiply that 4 with the 3 that's there. And then same thing here, multiply the bottom by 3, so you get a 6. And then that's v sub 0 t plus s sub 0, okay? Now they gave us 2 points on purpose. If s sub 0, or if I plug in 0, I get 0. Watch what happens. If this is 0, this is 0, this is 0, this is 0, what do we know that is? 0. So now they've actually, this part has told us that that is 0. So now we know this, that our function is t to the 4th over 12 minus t to the 3rd over 6 plus v sub 0 t. So it's a little more simplified from that part. So now we have to use this. If I plug in 6, I got to get 12, okay? 6 to the 4th divided by 12 is 108. 6 to the 3rd divided by 6 is 36. T is 6 now. Remember, if I plug in 6, I got to get 12. So this would be 6 v sub 0 has to equal 12. Now that's just an equation that's going to allow us to know what our initial velocity was. Now remember, our initial position was 0. We need the v sub 0 to get our final equation. So 108 minus 36 is 72. Subtract 72 from both sides, we get -60. Our initial velocity is -10. Now we have everything we need to make our position function. So our position function, our final answer is t to the 4th over 12 minus t to the 3rd over 6 minus 10t plus 0 you could put if you wanted to. So that is our final answer, okay? So if you know velocity or acceleration, you go backward once, velocity, go backwards one more time, that's position. And if they really want to be specific, they're going to have to give you some points or things to plug in. Otherwise, you just leave it s sub 0 and v sub 0 in the problem because you don't know, okay? So that one's weird. Again, that's not going to be on the quiz, but it is going to be there eventually. Okay. So it says for 9 through 18, use the form of the definition of the integral given in equation 3 to evaluate the integral. So that is just I'm sorry, just a minute. Okay, so 11 through 17 is the ones I want to concentrate on. That's what's going to be on the quiz, okay? So let's start with 9, okay? The boundaries are A and B. C is just a number. It's not an X. So to go backwards, we're just going to make that a C with an X on it. So remember, if a number's sitting there, to go backwards, it had to have had an X on it to not disappear completely. And then our boundaries are just 2 other variables. So the X's are going to come out. We're going to replace them with B's and A's. We're going to stick in the top boundary, so that's C times B. We're going to stick in the bottom boundary, that's C minus A, or C times A. We're just going to subtract. So it's always stick in your upper boundary minus the stick in on your lower boundary. For this one, we don't have a number, A, B, C, whatever those happen to be. Most of the ones I'm going to give you are like 11. Okay, so let's do 11. So we're going to do the antiderivative. So x cubed over 3 minus 2x. Put your little boundary marker there so you remember that you have, it's called a definite integral, remember, when we have those boundaries. It is always the function antiderivative of the upper bound minus the antiderivative of the lower bound. So we're going to stick in the upper bound. 4 to the third power is 64. So that's 64 thirds minus 8 minus 1/3 minus 2. Okay. Now, please always put your second portion in parentheses. The reason you want to do that is if you put them in parentheses, that's going to tell you that I have to subtract those things. So you can distribute the negative in if you want, or you can wait and get a number. I'm going to just distribute in. So 64 thirds minus 8 minus 1/3 plus 2. Now we have some things that are thirds and some things are not. So why not put the third stuff together? So that's 63 thirds minus 6. Now 63 thirds is just nice enough now that it is a whole number. 3 goes into 63 21 times. 21 minus 6 is an answer of 14. Okay, so remember, it is the antiderivative of the upper bound plugged in minus the antiderivative with the lower bound plugged in. That is the area under that curve. Everybody good with number 11? Let's move on to 15. Okay. Antiderivative. So we're going to do t to the 4th over 4 minus t to the 3rd over 3 plus t, because remember, any constant needs a t there. When we go backwards, the t always goes up by 1. And then we have our upper bounds, 1 and negative 1. When we plug in our upper bound, we get 1/4 minus 1/3 plus 1. And then we're going to plug in our lower bound. That would be positive 1/4. The negative 1 cubed stays negative, but there's a negative in front. So that's a positive 1/3 minus 1. And you will be able to use a calculator tomorrow or so, but I don't, you don't necessarily need one. Now let's distribute in the negative. So that's 1/4 minus 1/3 plus 1 minus 1/4 minus 1/3 plus 1. So it's nice that our 1/4s have canceled. So we just have some thirds and 1. So that's going to be 2 minus 2/3 or 6/3 minus 2/3. I want answers, please, in exact values. So leave your answers fractional. But you do have, you can use the red calculators that are on the back. Just give your answer in final fraction form. Okay. So let's do 17, and then we can go back over if there's any homework problems you were stuck on. We can look at those, the 4-3 homework. Okay, 17. So if they ask me to evaluate an integral, you ignore the bounds at first. We just do the antiderivative. So that's going to be x to the 4th over 4 plus 4x squared divided by 2, which is just 2x squared. And then I'm going to write my little boundaries on the side. Remember, at this point, it is always stick the upper bound into your antiderivative minus your lower bound. So if we stick b in, that's just b to the 4th over 4 plus 2b squared. And then always just check. Actually do the little math for a minute. If I stick in 0, do I get 0? In this case, we do get 0. But I kind of like it there, so then it reminds me that I at least checked, you know, that you actually check the work. And so your final answer for this one is b to the 4th over 4 plus 2b squared. Now, some things I'm going to remind you of, hint, hint, that might be helpful. If we have, let's say something like this. Yes. Look at the boundaries on this one. How much area is there between 2 and 2? 0. So there is one magically on there. If the boundaries match, there is no area to account for. So, you know, just so you note, there will be one that kind of something like that happens. Okay. Yeah, if you don't notice it, there is no way to evaluate that particular kind. So, yeah. So anyway, so there's going to be 2 that you're going to have to take the derivative of the integral, which is just the function inside. Plug in your variable. If the function is a not just a plain old x, but like x squared or x cubed or something, plug it in and then multiply by the derivative. And then the rest of them are just antiderivatives, plug in your bounds, antiderivatives, plug in your bounds. Okay, so, and then there's a few bonus on there. So that is your quiz. Now, you did have 4-3 homework. Can you tell me what page it's on in your book? Approximate. What did you say? Yes. Yours is in 358, so mine's probably 360 or so. Yeah, I do too. We're getting there. There's 4-4. Okay, so here's your 4-3 homework. Can somebody tell me what it actually was? Like what numbers you were supposed to do? 3 to 37 odds? Okay. Okay, so from the homework, let's look at ones that are more like what we're going to see on the quiz tomorrow. Okay, so this is your 4-3 homework. For me, that was page 354. Okay, so the first 2 questions are about the fundamental theorem of calculus part 1, which says that the derivative of an integral is the function inside. So number 7 says to find the derivative. Well, the derivative of this is just 1 over x cubed plus 1. Now, that's because the boundaries are a number to x. Okay. Now, let's look at one that has a function up there. Let's do 16. Okay. Well, no, your homework was, let's do 17. Okay. So you do just get to stick in the function 1 minus 3x. So I don't need any simplification. 1 minus 3x cubed over 1 plus 1 minus 3x squared. Okay. But there's two things we have to account for. One is that our function is at the bottom. It's our boundary. And what do we always do? We subtract the bottom. We don't add it. So we do have to put a negative out in front because it's in the bottom. The other thing we have to count for is we have to multiply by the derivative of that thing. The derivative of 1 minus 3x is negative 3. So that is what the first two are going to look like. Okay. Now, the rest of the quiz is all about the ones like evaluating integral. That's all there is, evaluate the integral. Okay. So let's just look at 19, and then I'll pick any ones that you might have been stuck on for the quiz. Okay. Okay, let's look at 19. So remember, we're going to antiderivative, upper bound minus lower bound. Okay. So the antiderivative is x to the 4th over 4 minus 2x squared divided by 2, which is just x squared.
Right, the one number part just goes away. 2.
Because we divided by 2. Yeah, because you remember you divide by that new power. So you could have written negative 2x squared divided by 2. It's the same thing, and that's okay. It doesn't hurt anything to write it. I simplified it down. No, I simplified it down. I simplified it because I knew I was going to plug in numbers. So if you can simplify it a little bit, it's helpful because then when you go to plug stuff in. Okay. Now remember, it's always upper bound plugged in minus lower bound plugged in. So if we plug in 2, that's 16 divided by 4. 2 squared is 4. And then we're going to minus in parentheses when we stick in negative 1. So that's 1/4 minus 1. And then the 4's canceled. If we distribute it in the negative 1/4, we get negative 1/4 plus 1, which is 3/4. Always subtract upper bound minus lower bound, upper bound minus lower bound. Okay. So I think you know those. Now let's just, you were supposed to do up to 35 or something. Were there any particular ones that you wanted to see from your actual homework that anybody had a question on?
Can we do one more that we did like the first 2 questions?
Yeah. Okay, let's do 15. Notice we want the derivative. So we just got to stick in the functions of x, and there's only one of them. Okay. So, and it's in the correct order. So it would be the square root of the tangent of x plus the square root of the tangent of x. Now, we have to multiply by the derivative of the tangent of x. So you just put a secant squared of x out there. That's it.
Will there ever be like a tangent x and secant x?
No.
They'll just be 1.
Yeah, they'll just be 1. Yeah.
What do you mean by it was in order?
Oh, so if the tangent is your lower bound, then you would put a negative in front.
Like in front of the whole square root?
Front of the whole, yes. Okay. Any other questions that you would like me to do from your 4-3 homework? Does this make sense?
The first stuff does. The other stuff, you have to rewatch the notes. Like I said, I
Yeah.
completely missed the notes.
Dan, did you have a question?
No,
Okay. Yeah, me too. That's good. Yeah, that's good.
actually,
I don't know. I don't know. No. Any other questions that you want me to do from the homework?
What about 13 makes it like highlighted? Like, why is 13 highlighted?
Oh, because they're trying to remind you that the derivative of 1 over x, has a little rewrite, so your 1 over x, you would write as x to the negative 1. That's that negative. No, no. Yeah, so I think they were just reminding you that 1 over x is a funky derivative. Yeah, they usually highlight the ones that are have just a little twist to them. Any other questions about your quiz tomorrow? Yeah, the d theta looks strange, doesn't it? Yeah. So remember, like 25, that would just be negative cosine of theta. But you do have to remember your unit circle. Yeah. So it would be the negative cosine of pi minus the negative cosine of pi over 6, which would become a positive there. So yeah, you do have to remember what is pi over 6. Pi is 180. The cosine of that is negative 1. Okay, in radians, pi is 180 degrees. Yeah, okay. So that would be what? 1 plus square root of 3 over 2. And you would just leave it. You can't go further. There's one that has unit circle values in it, just one. But there's 3 bonuses if you miss anything beyond that.
So bonus is like additional questions?
Yeah, no, they're just questions.
And they're not like harder.
One is pretty good, one is disgusting, and one is pretty darn good. Yeah.